Welcome to today's Explainer. We're tackling a concept that, honestly, feels like pure science fiction, but actually has deep roots in modern physics. We're talking about parallel universes. Now, if you think this is just comic book material or movie magic, prepare to have your mind completely expanded. We're going to demystify this whole idea by grounding it firmly in hard science. It's a thrilling journey, so let's get right into it.
Let's start right here with a simple question. What if there are literally other versions of you? It's a massive pop culture trope right now, isn't it? We see it everywhere. This idea that somewhere out there, another you is living a slightly different life just because they made one different choice. Maybe they took that other job, or, I don't know, moved to a different city. It's incredibly fun to think about. But what if I told you that the world's leading physicists take this very idea incredibly seriously?
Okay, let's dive into this. Because here's the thing. The multiverse isn't just a convenient plot device for a summer blockbuster. It's actually a serious mathematical and physical probability that emerges from some of our most successful, rigorously tested scientific theories. We aren't dealing with magic or fantasy today. We're dealing with the logical consequences of how our universe operates at its absolute most fundamental levels.
So here's our roadmap for this explainer. First, we'll zoom way out to the macro scale to look at cosmic inflation. Then, we'll shrink all the way down to the micro scale to explore quantum mechanics. And finally, we'll bring it all home with some existential conclusions.
All right, kicking things off with Section 1, the macro scale, focusing on cosmic inflation. To really grasp this, we have to go back, way back, to the grandest scale imaginable. We need to look at cosmic inflation. Proposed by physicists back in the early 1980s, this theory was actually designed to solve some glaring anomalies in the standard Big Bang model. Like, why the universe looks so uniformly flat and evenly distributed in all directions. The theory suggests that just a tiny fraction of a second after the Big Bang, the infant universe expanded exponentially, ballooning outward way faster than the speed of light. It's a foundational concept in modern cosmology.
Now, to picture what happened next, try to imagine our universe as a bubble. Just a single bubble floating in this vast, continuously expanding cosmic ocean, where new bubbles are constantly emerging. This is a fascinating scenario known as eternal inflation. It suggests that while this incredibly rapid inflation stopped in our particular cosmic neighborhood, which is what allowed our specific universe to form, by the way, it didn't necessarily stop everywhere. Out in the vast, underlying fabric of space, this rapid expansion just keeps going eternally, spawning countless isolated bubble universes.
And man, here is where it gets absolutely wild. These bubble universes, often classified by physicists as level 2 multiverses, wouldn't necessarily look anything like ours. Because they formed in completely separate inflationary pockets, the fundamental constants of nature might have settled in entirely different ways. Imagine completely alien environments where gravity is overwhelmingly strong, or where there are, say, more than 3 spatial dimensions, or where the fundamental particles are entirely unknown to us. The actual physical laws themselves could be drastically different from what we experience every day.
Now, I know what you're thinking. Well, how could we possibly know if these giant bubbles exist if we literally can't see them? But scientists are actually actively searching for indirect evidence. They're looking for what they cleverly call cosmic bruises. The idea is, if our bubble universe bumped into another bubble universe in the deep, ancient past, it might have left a mark. A specific distortion in the cosmic microwave background, which is the radiation left over from the Big Bang. They also look for unexplained behaviors in high-energy particle physics that might hint at interactions with hidden dimensions. It's literally cosmic detective work.
Let's move on and see how this builds in Section 2, the microscale, diving into quantum mechanics.
So we're shifting gears now, from the massive cosmos all the way down to the bizarre, microscopic realm of subatomic particles. And let me tell you, the rules of common sense completely break down here. Take quantum superposition, for example. It's the scientifically verified principle that a subatomic particle, like an electron, doesn't actually have a single definite state until you measure it. It can literally spin in multiple directions, like up and down, at the exact same time. It just exists in this blur of multiple probabilities until the exact moment of observation.
Think of it like a quantum coin flip. Step 1, the coin is in the air. In the quantum world, it is both heads and tails simultaneously. That's superposition. Step 2, the coin lands. A measurement is made, an event definitively occurs. Now what happens to that other probability? Well, back in the 1950s, physicist Hugh Everett III proposed the many worlds interpretation.
Step 3 of our coin flip tells us that instead of reality just collapsing into one outcome, reality itself splits. A new universe branches off for every single possible quantum outcome. So in one universe, the coin is heads. In another, parallel universe, a version of you is staring at tails.
Now, what's really interesting here is the stark contrast between these two scientific paths. On one hand, we've got our level 2 bubble universes. These are born from macrocosmic expansion, and they feature drastically different laws of physics. But on the other hand, we have level 3 quantum universes. These are born constantly from subatomic measurements and branching choices. These quantum universes share our exact physical laws, but they contain entirely different histories and different outcomes. So one is a multiverse of space, and the other is a multiverse of probability.
Which brings us to our final segment, Section 3, Existential Conclusions.
Honestly, you can't talk about these massive scientific theories without bringing it all down to a deeply personal level. If we objectively look at the implications here, we run into some serious dilemmas that physicists and philosophers debate endlessly. First up, do we actually have free will? I mean, if every possible choice you could ever make is simply realized in some other branch of reality, are you really choosing or just following one inevitable path? Second, is our universe uniquely special, or are we just an insignificant drop in an infinite mathematical ocean? And finally, if there are alternate paths out there where things went better, or frankly much worse, does that diminish the value and meaning of the individual life we're living right now?
It's a lot to wrap your head around for sure. It can feel pretty overwhelming. But the crucial point is this: your specific journey through this specific universe remains profoundly unique to your conscious experience. Even in a mathematical multiverse of infinite branching, you don't experience all those other branches. You only experience this one. Your choices, your triumphs, your mistakes, they hold undeniable personal meaning to the conscious you that is right here, anchored in this very reality.
So that leaves us with this final, provocative thought to close out. In a universe, or, a multiverse, of infinite possibilities, what makes your current version special? While science continues the hard work of searching for the empirical evidence to prove or disprove these parallel worlds, the sheer awe of these scientific foundations forces us to look inward. We aren't endorsing the multiverse as an absolute fact today, but rather marveling at how our deepest physics opens up the absolute grandest questions. Whether we are a solitary bubble or just one of an infinite number of branches, the reality you are building today is uniquely yours. Thank you so much for joining me in this explainer, and I really hope this leaves you staring at the ceiling tonight, wondering about the universe and yourself.